and welcome to virtual learning with the Civil Software Education Hub. So on this platform we will try to provide a very basic and important software based learning. The software we are using practical on our fields. So today our lecture is all about how we will prepare an analysis, do the analysis and design of retaining walls in SAP 2000. Normally every structure engineer knows that what is the procedure, what are the procedures to design, to analysis, to consider the demands and to counter the demand, provide the structure. So normally retaining walls we have three or four types: gravity retaining walls basically, and other is structural retaining walls which take the load by structural action, other gravity by its weight. So today in SAP 2000 we will learn. So gravity retaining walls actually is a simple, quite simple than structural based retaining walls. So first of all that you should know about Civil 3D is a CSI software which provides a better results and reliable results, accurate results. If your inputs, if your uh, uh, input is okay, the result will be okay. You can check, you can do a cross checks. So let me start to introduce the interface of SAP 2000. In every video we will uh, try to show the basics first of all, and then we will provide the further necessary relevant of that lecture. So here you can see that this is your points here, this point. From here you can set your units of the current project. So my current file have, I put a kilonewton meter. This will be this will be my units, SI units. This. So my file will be set on the base of this units. So let's go and make new file. Click here or Control N. So I just click here N. So today my plan is to make a retaining structure. Basically a retaining structure is, to understand the concept of joint pattern, how we will use the joint pattern in SAP 2000. Joint pattern is basically used for so let me show you on the some PowerPoint slide. SAP 2000. SAP 2000. So in SAP 2000 actually in SAP 2000 we will learn about we have come with this dialog box. So this dialog box is for new model. So we have already selected already templates. Like here we have blank, grid only, beam, trusses, every different templates are there. So now I am going with my retaining wall for a joint pattern. So I will select grid only. So today my plan is to model a simple retaining wall with one wall. Okay, so it will be fixed support from the bottom, so like a single wall. So let me do the modeling first. Okay, define the grid lines. So let me define the grid lines. X direction we have two points. These are the points. Actually these are the points, you need to understand this one. Y direction I have 2 points. Y direction I will put 1 point. Okay, in Z direction actually the elevation I will put 2 points. X direction the spacing will be let me consider the spacing is 4 meter, because my unit is already set in the beginning. So here in Y direction I will put let's suppose this is actually I defined, but there is a only 1 point, so 1 point cannot be transit into, so it's meaningless. If you can put it 0 or as it is, no problem. So here I will put is in Z direction I will consider is 3 meter retaining wall. Okay, or you can put into 10 meter, but I will put it 3 meter. So you can press OK. If you have pressed OK, so this is the preview of we default. We have two windows. So here you can see that XY, this is you can see that this is will be XY direction. So let me do the same procedure for the other one. So you need to click here, and from here you can choose your direction. Here is we have the views. So YZ, no, I use XZ. Okay, this will be XZ. Okay, vertical and horizontal. So this is our grid. So you need to click here to fit the screen, but our grid points are hide. So here are our grid points. Okay, so you can also change your display. Your here is our tools, and from here we can change the window to one window. So I keep two because I want to see this one into in this direction also, 3D view also, and XYZ also. So first of all I need to define my, this is a very important tab, very important tab. You need to concentrate on this one. First of all, if you are a beginner, if you are not done previously, so you consider the importance of the material. So let me do the material first. I will select the material here. This will be the dialog box open here. So in this dialog box previously default defined two materials here. So I can add my material depend on my available concrete or available steel. So available lab tested concrete by some lab person. So here is I have, let's suppose my project I am using 3000 psi concrete. Okay, let me click OK. So here is 3000 psi concrete. I will modify it and I will name it C28. Okay, C28 because I am working in kilonewton per cubic meter. So here is also you see that this actually this is not C28. It should be C20. Let's suppose I will use C20 because my concrete is here C20. So this is concrete. You need to click concrete and you can change the material name and display color. So unit weight, you can put in this unit. Here is unit weight. Okay with me. Elasticity modulus, Poisson ratio, everything is okay. If you are so this I need to click OK. Then I again define material, add new material. So here is a steel, everything. So I will click here rebar. If I click here rebar, automatically software will understand the unit weights, elastic, Poisson ratio, coefficient of thermal expansion. So it will automatically fill this one. So here I will go and I will use G60. So you need to understand the G60 value is here is a 4 tensile expected. So here is you need to change. So I will go, instead of this, for doing some background calculation, I will go and add quick material. And from here I will choose grade 60. Where is grade 60? Here is no grade 60 available. Grade 50. So let me check first the material type first. Rebar grade 60. Okay, so now you can go and modify material. Okay, if you modify material grade 60, then you need to grade 60. If you have grade 60, so from here grade 60, here already you have the FY and F, these things are available with you. So now I will go and I will click OK. If I click OK, I will again click OK. So I have defined materials. Remember that we first defined material. So defined material. Now we need to define sections. Section, we have different sections. I am always instructing that don't go behind every and each command. You need to focus your requirement. Extract that when if you are going to market, you are not buying whole market. Remember this one. You are just buying your required and intended groceries. You are focusing on your item which you need to purchase, but you not buy whole market. Thank you for this one. So this is software also like that. You need no need to consider all and every points. You need to only consider your intended and required point for the relevant project. If let's suppose something is new for you, you need to learn that for the project and extract that one in your another project in the future. So thank you. So for this section properties, I need to do the cable section, tendon section, but frame section was very important because normally we are doing frame structure in the SAP 2000 and ETFs SAP actually for the slab and footings. We will do also, actually we have the lecture also in the playlist in very detail. So for this one I will go area section. Okay, because my retaining wall is area section, you need to consider that one. Actually modeling is not the thing inch to inch, not the thing centimeter to centimeter. You need to consider in your brain, and you can correlate. You can correlate and you can do the modeling of the most probable or most close to your existing structure or existing or planned section, planned structure. So we have the shell element here, plane element, air element, whatever. So in my case shell element, I will add new element. I will call is wall, because retaining wall, retain means to support and wall means wall. I will consider this wall and this will be the thin wall. I will choose my material from the drop down. I will see 20 and here is angle, no need to consider. Membrane thickness I will consider. Here is round about 200 mm. I will just enter 200 mm. Here I will again bending also I will put 0.2 or sorry, same. Modifying, if you are very familiar, and you can save rebar material from here. Okay, you do not let this modify and show concrete shell design parameter. Okay, so you just click OK. Click OK. Now we have defined our section. So let me click here. I just clicked and I am come out from my command. So we have defined section also. Now we, in case of wall, in case of water tank, in case of the structure which support pressure, we need to apply joint pattern. Okay, so I am in market of this defined and I will buy joint pattern. I will just click this joint pattern. I will just click this one. If I click default, some joint pattern is it, I will add, so no need of duplicate change name. So let's suppose I will add a new joint pattern. Here is wall pressure. Okay, pressure, wall pressure, wall pressure, sample like this. Wall pressure, add wall pressure. Okay, from we have defined material section wall joint pattern. Now we need to go to the load patterns. So this load pattern I will apply, already dead load is there. I will apply water pressure. From here type I need to change this one to more. Click here, more. From more I will go to the water pressure. Other here is a horizontal earth. Oh yes, not actually not. I'm so sorry that we have used water pressure. Actually not. We are going to design the water tank. So I will choose as earth horizontal earth pressure. Okay, from here earth pressure, E pressure. Okay, so gel pattern will be the same. Okay, self multiplier here is 0, so it's a dead load. So dead load 1 means that the structure itself load. So I will add button is, don't forget to press this one, add. So now your joint pattern is in this list, so I just click OK. I will again go and define, again define. So you need to consider and reconsider if you have done something. So I will choose here is a earth pressure. Okay, E pre for my shortcut. Yes, what did I done? Let's joint pattern. E pressure and delete this one. Okay. So we have done with the joint pattern, load pattern, load case. Actually, if you not define any load case, the running analysis result will not be shown to you. So you need to consider. For model case I will ignore, because I'm not doing the model analysis. It's for pure dynamic analysis. So let me delete from my load case. Other two are okay with me. Then we need to go to the combination. So if you are a very beginner, so you need to consider this one. Other people who already knows SEP 2000, no need to consider to provide this. So I just add here, I just also pressure head. So okay, now we have done with the define tab. So in the definition tab we have done everything. So actually this is I have done, you can first material section, then apply, then again come. So I just done all things in the row from the definition tab. Okay, it depends on your method. So let me go and check this retaining wall. So first I will go here. I have three options. All these are options are available, but I have no such kind of frame are going to design. So I will choose this one. Here is a quick draw, rectangular draw, this draw poly area. Something is not a symmetrical or rectangle type, so we will use that one. And this is for the quick. So just I click here, wall. Already this section, you make sure that this should be wall. If you press none, so your property will not be applied. I click just here, and then you need to close this one. I want to check this wall. So extrude view. Okay, so fill area. Okay, fill area, fill object, apply. Here is other fill areas, sections, property, object. Okay, so this is our wall. So I need to mesh this wall. So in this lecture, you also learn about how to mesh area elements. Area elements are necessary to mesh, to do the meshing, because we are doing the finite element method. Finite element means on the pixel type, because if we whole area have different characters, so if your character is localizing in a small boxes, so this will be provide you the good results. This is the purpose of meshing. So just click shape, tab have different approaches and different little bit different commands. Concept is same. So let me go and edit areas, divide areas. So here is a divide area into small pieces. So I just go and this. So here we have different into objects. So here we have the different options. Divide area into object of maximum size. So I will put 1 by 1 meter, okay, or 0.5. It's depend on, if you decrease these numbers, your analysis time will be more, and it will take time. So it depend on your mind. So as a beginning, I told you that if you are going to model something, you need to, in every software, not in SAP 2000, you cannot make the actual one in computer or by your hands. Actually you need to go very close, 80%, 90%, but you cannot 100% model the building in softwares, in by manually. So you need to go close to that one, so you can provide, you can guess and you can provide. You need to understand the structural concept. So let's go and do the meshing. Just okay. If I click here, my meshing both windows are already appeared. Okay, so here is also appeared. So first of all, in SAP 2000 ETF CSI software, you need to provide supports. Even in your real life, even everywhere, you provide the section for the structure. You need to provide supports, and everybody knows about three type of supports. Three type of supports are here. In SAP 2000 we provide rolling support, roller support, hinge support. Here is joint, assign joint. So restraints, two names. Restraints, joint have different types. So one is restraints, supports. So I click just here. Restraint I need to click. Just go assign, restrain. I provide fixed support here, because downside surely I have the paired there, heel there. So I'm just deliver you the concept of joint pattern. I deliver, I click here the fixed support. I just click OK. So this is my fixed support in both 3D and in the XZ window. So from here you active your window and you can rotate and check. But normally if you are understand this one is okay, so no need to rotate these things. So you need to understand the concepts. From one thing I want to add there, you can go and sections and material base, so you can apply. Our material concrete was like this. Okay. So this is how we use this check sit display option. How can we use? Control E. You can use a Control E shortcut for this one. Okay, if you are missing this step from this toolbar. So we have done the definition and we have edited into meshes. Now our main point is that how we will apply joint pattern here. So let me click this face. In one playlist we save 2000, we have already provided water tank on. Actually water tank have four sides because we have rectangular water tank. So four side we have applied the water pressure there. So the same concept is here. We are providing the backfill pressure here. Okay, so let's go assign. Here we have joint pattern. Okay, now we are in assign tab. First define tab completed. You need to edit some changes and then you need to follow the selection draw. This draw is actually we are doing from the draw from the toolbars. So we are skipping this. So bridge actually we don't have. So here from selecting we are doing directly from the window. So we can select from this also. So let me do this also, because if you need to go for different ways, it will be better. So selection, so from selection I will go select rolling, select properties. Let me go to select properties. So actually I can select C20 also like that. And another way is that escape this one first, select this one. From here I will go material to frame section, area section. So actually area section I have wall, so I will select this wall. So now my wall is already selected. Okay, so this is my wall is selected, assign. And actually if you have wall selected, you can only apply the area loads. Okay, so in this case we are going to select these joints. Okay, so we are selecting joints. So frames, joints, materials. So from tendons, area, link property. So actually we don't have link property, so we will select like this from our window. If we select like this, so these joints are already selected, the meshed joints are already selected. So we will go assign joint pattern. So joint pattern, you need to understand this one. You need to understand this window. This is very important. It's just like that you are doing plaster and you are not doing the paint and rendering on the surface. So it's also same like that. This is the 25 minutes effort and 25 minutes hard working. We cannot let this point without understanding. Okay, so we are going from this point. I will select my pattern name, which I have defined in my define tab. So I already defined that one here. So here is one equation. I will go with the first one. So actually that equation, pattern value equal to ax plus by plus cz plus d, and here is the input cells. First constant I will consider 0, second constant I will consider also 0, because this is totally the boundary conditions. Okay, I will consider a, b and c both are 0, because this will be my free end, ax by. Okay, I will consider this one as a 0, because I am starting from the bottom to upside. So if I consider the boundary condition at bottom, my x value and y value like 0. So first two I consider 0. This is my boundary condition. Second, here is C. Actually everybody knows and try to know that soil backfill pressure. We know that 9.8, 9 I will write here, 9.81 for water. Okay, so this is kilonewton, because already I have set my unit here. Okay, you need to understand this one. So I will put here, actually this is my backfill. I consider my backfill is 20 or 18, because soil is around about 20 or 18 kilonewton. I will consider my backfill is 18. But I will change the sign minus here, because if I put all ax by, this factor will be 0 first two, then c is equal to this pattern is equal to 0. So let me do this rehearsal in ETABS, sorry, SEP 2000 in the PowerPoint. So here is, I will draw 0 is equal to, it should be empty, so it will work. 0 is equal to 0 is equal to ax by mouse. So I will provide you this typing here. So ax plus by plus cz is equal to, so in this case these two factors will be 0 because boundary condition we applied. So these two factor will be 0, and then we have cz and plus d. So cz will be in this right side, sorry, d will be in the left side. So z it will be come with the negative sign. So this is very basic mathematics. So divided by z, okay, so divided by z. So let me do the procedure that I will shift this d here. So d we have how much value the d we have. So let's we apply that d value divided by gamma unit weight. So we have this equation, pattern value. So here I try to draw this equation here is equal to, this will be at the bottom, then it will come to the top. Okay, so here we have the provide x and y 0, so automatically a and b. So if we consider is z is equal to 0, so depth will be 0. So both we consider at the bottom, so in the bottom it will both become 0. This okay. So now here we have the c value. Is from the equation cz plus d. If we cz plus d, c value will be at the elevation of if the height of 3 meter. So it will be, because our height is 3 meter. So we will use the negative sign here, and we will apply the unit weight from the calculations here. Okay, because at the z elevation is in the top, we have the pattern value will be 3. So other values will be considered 0, and this will be d will be go the other side. So it will neutralize, and this will be 18. So at the d value actually equal to cz, so it will multiply c into z. So c we have 18, so multiply by c into 18 multiply by 3, because we have the elevation 3. Replace existing load, if there is any existing load is there, so replace, it will calculate it here. So use all values. Okay, joint pattern application assigned. So we will go in previous selection. From previous selection, I will go assign. Now we will assign uniform shell load. We have surface pressure. So actually our retaining wall is facing a surface pressure from back surface, from the hillside or from the retain side. So I just click here the surface pressure. From here I will choose surface pressure, E pressure, which I already defined in the joint pattern. Okay, so this is by element. No, I will use by joint pattern and E. So multiplier is OK1 from the top. Okay, from the top as it is, replace the existing load. Okay. So now we have apply this joint pattern here. The value is here. So let me go and check in the 3D model to display so show load assign joint loads. No, I am not applying here. I will show loads, area loads, the pressure. So here we can go apply. These are the application of my loads, and here is the legends. Here is the color intensity from 0 to the maximum at the bottom, because actually this is act as a cantilever. So cantilever, you understand that cantilever have maximum demand at the support side. So support side is the bottom side here. Okay, so we can show these loads by some arrows. Go show load case, area load. Here is a top. So show surface pressure values on the face. So here is we check this option. So I will okay. So these are the arrows. Here is the big arrow, means that bottom side have maximum pressure, top have less pressure. So therefore this is our concept that if there is a retaining structure, backside pressure will be like a wedge type, like a rectangular type and wedge type, because this is the 3D. So 3D of a triangle is a wedge. Okay, so this is all about the pressure application. Let me go and run the analysis. I will go and run the analysis, and just I will click here. It will take time and think. The ground calculation is ongoing, so do chill. So this is E pressure already we have. So let's go the animation. Let's see whether our it's a nice view and also a good music. So no need to disturb others to reduce the volume of your PC, and I am not also disturbing you. So if you like the video, so please subscribe and share with friends. So in this case, animation is not for the only you happy and see that this is moving. So this is I have done big thing. No, it's just for you understand that you are whether your E pressure, joint pattern, load is applied or not. This is for the purpose, because we are engineers, so we are not believe on the only animations. We need to believe our safety, economy, and we should consider these two factors, safety and economy. We should not throw money in the ocean or in the river just without any cause. So our structure should be safe and should be economical within the budget. So this is also very important. So this is I stop and I will check my design here. So I will go, because actually you need to consider that E-tape is not reliable and compatible with the shell design. We will go shell design, slab, footing, wall type in safe. E-tape is normally for buildings. SAFE 2000 in general. but all have the same concept, all have the CSI software have almost the same concept. So for the beginners I will prefer to use SAP 2000. So here we will go and display. We have display a deform shape, we already understand. We now shell display. So here we have different components. You need to search one by one, then in manual. So these are resultant force, shell stresses, concrete design. I will first go shell stresses. I will just click. Here other things you need to consider E pressure for, but you can use for designing a combination. So here is contour, range maximum you can provide, stresses, averaging, show, deform shape, okay. So here visible face, stresses. So these are the components. These are components you, if you are you can check one by one what are they. So in this video we cannot consider this in detail. This will take a lot of time. So just click OK. Because now it's moving, so you can consider this is the stress S11 diagram here. So these are the maximum and these are top is the minimum. So I will go again display. Normally some people are doing very well in the beginning, and at the end they will not provide you the good results. They just limited themselves to the model, so it's not a good way to limit yourself in the model. So normally, so I will show you the shell element here again. So concrete design, here is visible face, okay. There is 3 AST, AST1, AST2. I will apply show, okay. So this is our AST1 diagram. It means that this reinforcement. So if I will show you in the next AST2 diagram. So you can consider this one and make a picture in your mind. I will go again display, show shell. I will press OK. AST2 diagram. This is the reinforcement. You know, this is this reinforcement. Previously was this type of reinforcement, okay. This type of reinforcement, AST2. So here you can consider the AST2 faces, local axis. So you need to consider this one. So let me show this one. Stop this animation. I'm not going to any more animation. So I just go XZ. This window already selected XZ. Here XZ. Here you can see that this is your unit. So I just click one cell. From this cell you can see that this is my support area. This is the support area. This provide you the reinforcement. So normally every person saying that SAP 2000 is not good, provide you the shell element design. So this is totally not a good idea there. So you can calculate this by Excel using getting these results from SAP 2000. It will, but normally SAP is a very good. You can do the drafting there. You can check your reinforcement, because we are not going to do the design of finite element method in our practical life, because you cannot go each and every cell have different reinforcement. It's practically impossible. So what should you do? You need to consider steps: column step, middle step. So SAP is a reliable, and SAP have the option of using middle strip, column strip, and it will be on the strip based design, not a finite element based design. You can do, but you can take some one or two or three cells from this point, and that cells you will do in the Excel calculation. Because here if I take my point is here, so it's meter square per meter. This is the area of steel bar per meter, okay. So per meter means this length or this length. It's depend on your uh, direction of reinforcement. Okay, so these are two AST1, AST2, I already told you. So I will change here from my units, so you can change. It's not too much fixed there. So here if you change this one, so this your element will be in millimeter per meter. So per millimeter, this much millimeter square reinforcement you require. So you can put your number of bar reinforcement there and multiply or divide some arithmetic calculation you do. So today's lecture is we are going to conclude that. So we have learned about how to do a modeling of retaining structure, even it's retaining wall or other structure. In this model we can compare and we can do using this concept by water tanks wall, some dam wall. So small dam walls, because dam have other calculations also required. If someone say that if I can do this calculation, I will go to the design a big dam, so it's not